Hi, this is Tim, and today I want to talk to you about using simulators. And this is a discussion that I have probably sat on the fence too long on, even though I have subtly hinted at it. But folks, if you're using a simulator, you're not going to get a job. And I've been letting this one simmer. Actually, it's been simmering for about 5 months, and I just can't get it out of my head. And that's why I was like, all right, I got to go ahead and hit the record button on this. But I was at a conference and they were asking about how, schools, especially cash-strapped schools, because I know, it's not like schools have an unlimited budget, but how can you put students in front of industrial hardware on a budget? And one of the panelists said that with modern PLCs, that you didn't need hardware anymore. There were simulations for everything. Folks, I'm gonna spin around this room here, and I will tell you right now, there's a boatload of money in here, and if I could do this with simple simulators, then I would, but it simply isn't true. I get to learn about a lot of different schools' hardware. Hopefully, I still get to learn about their hardware after this video, but what I can't figure out is every technical college, every two-year college has some of the best hardware that rivals mine. And I do believe I have the best hardware in the US. I can't swear about the world, but every four-year university has almost nothing. But I want to give you the 5 reasons that really simulators are going to let you down. And number one is simulators do not actually emulate the hardware exactly as you're going to see it in the field. Now, that can seem like a small deal, and arguably that is a small deal if we're just testing the waters. In other words, nowhere in this video am I saying that simulators don't have a place. I mean, simulators allow us to learn the basics of a lot of items without a lot of hardware investment. Well, that is a good thing. But okay, now if we extend that simulator on to actually, can we test code for deployment, then I will say that I have not found a simulator software out there that there isn't some nuance in how it actually operates out in the field. Now, why is that important? Because, if you go and you test you test your code on a simulator on a system that you're actually going to deploy live, then when it doesn't work, is it because there's an issue with your wiring, which chances are if you're using a simulator, you don't even know exactly how to do the wiring? Or is it because the simulating software doesn't work exactly the same as the PLC, but the simulators work in perfect world? There is no latency. There are no networking issues. There is no signal noise. I know our simulator switches just on or off. The idea that, we may induce noise on a line because we ran it parallel with a 480 volt motor, those are things that simulators can't really take into account, which kind of goes to number 2, which is wiring. Wiring is arguably the most important part of your job as a PLC programmer. We're not even talking about technicians yet, but probably the number 2 call. Number 1 call I get is, hey, I think I know how to program a PLC, but I can't figure out how to connect to it because everything was done for me at my school. That's number 1. Number 2 is, hey, I think I know how to program a PLC, but I hooked a wire up to my switch and the light on my PLC isn't coming on because you didn't learn actually about wiring. You didn't learn about syncing and sourcing. You're not even sure what the difference between a discrete input and a analog input is. Did you need an NPN or a PNP sensor? All these type of items, these are the costly items when we actually get out in the field. Number 3 is real world troubleshooting. Simulators, they're very forgiving. You can shove a simulator in your virtual enclosure and it will never have an issue of overheating. It will never have an issue of moisture. My goodness, if I hear another one of y'all putting a Raspberry Pi into a piece of wire duct, that first of all, that is against code. Second of all, even that little cute little thing, it does build heat. And so we don't learn all those design factors, such as, transformers build heat, drives build heat. And you cram all this stuff into a small panel, and all of a sudden, your panel's cooking. That's not something you're going to learn using your simulation code. Number 4 is real world devices that the PLC integrates with, especially now. Now, I'll say maybe, actually, I've been I guess I'm getting old, folks. I've been in this industry, 30-something years. Maybe at the beginning of it, we might could have said that you only had the PLC, and if you understood some addressing, you would be okay. But almost every device out there actually connects over a network to your PLC. So you got to understand how to integrate with, right here, we got to learn how to integrate with this G120 drive on Siemens or this PowerFlex 525 drive. Both of those are coming over Ethernet. We have IO-Link. That's picking up a lot of our smart sensors these days, including this encoder. So it's not just simply, hey, I flip a switch on and, hey, I know how to do a flip-flop or know what a time-on delay, time-off delay is. There's a lot out there as far as things that we need to integrate out in the field. You have HMIs, you have SCADAs, you have all types of acronyms out there that go well beyond your little bit of simulation software. And number 5 is probably the important one as far as equipping you to a job is industry standards, I'll say, or I'll say job requirements. You're not going to take and put on your job application, I learned how to program PLCs with a Raspberry Pi simulator and get a call back from a plant. They're going to want to know that, hey, you know how to program an Allen Bradley PLC, or maybe more specific, you know how to program an Allen Bradley Control Logic PLC in Studio 5000. You know how to program a Siemens S7 1200 PLC, a Beckhoff PLC, an on-run PLC. I have never seen a job requirement that says you must know how to program PLCs and Raspberry Pis. It just ain't going to happen. So what are these good for? First of all, they are very good for try before you buy. And I will say this, before you sign up for a PLC programming class, or even if you purchase one of our trainers, you'll notice if you go through the lessons, my first lesson in the connected components is saying, hey, now some of you are on the fence about buying a trainer. Don't do it yet. We're going to use a simulator, and we're going to make sure that you really are interested in learning this before you actually invest in hardware. There's the perfect spot for a simulator. Or, you're evaluating some new hardware at your plant. Then, yeah, maybe, I'm like, hey, I've always been an AB user. I kind of would like to play with Siemens. Well, yeah, TI Portal has a simulator in it. So it'll kind of give you a little bit of, okay, how does the little thingies react on the screen? Things like that. Another one is, I will say our really budget-strapped programs. And I'm going to stop at high schools on this one. If you are in a college class, if you're in a 2-year class, if you're in a technical school, my goodness, if you're at a 4-year university and they are using simulations and ask for your money back. If you're at a high school, though, high schools are very strapped. And, they're trying to sprinkle ideas about what you may want to do in the future. There's a perfect place for simulators. Now, I do want to stress, since I already mentioned the 3 places that simulators are very bad for and why they're very bad for them. First of all is internal company training. Your company has a compact guard Logix PLC out on their line. You need a compact guard Logix trainer from them to be practicing on, because you want them to practice wiring that thing wrong and figuring out how to troubleshoot wiring it wrong. And you want them to do that over and over and over again until they have the muscle memory. That way, when your line goes down, they can naturally go out there and troubleshoot it without thinking. Now, my trade schools and my 2 universities, first of all, I'll give y'all mad props. Out of all the schools, y'all are the ones that y'all send me pictures, or I see, I do watch LinkedIn, I watch Instagram. Y'all do amazing things with the hardware that you have available to you, and I commend you for that. I see, creative ways that you're using the hardware together to try to simulate factories and keep that up. Now, if some of you are like, oh, well, we don't really have that. We only have simulators. Let's think about it. We're, as a 2-year or a trade school, we're trying to put someone out with marketable job skills right away. And we're not going to do that using simulators. I mean, the company is going to want to know that, hey, they've worked on this Siemens S7 1200, if that's what they use. Or, they've worked on this Allen Bradley PLC. And we're going to ask if you ever worked on a Raspberry Pi before. And then finally, my 4-year universities, for graduating people out of school, and they contact me all the time because, first of all, they've racked up a bunch of debt and they're like, hey, can I come to your training? I can't get a job because I don't have experience. And, I had to break to them, hey, my training, even as hands-on as it is not experience. And, when I talk to the HR departments, they're like, yeah, we can't take someone right out of school because they've never seen an actual piece of hardware. Now, we can solve that. We can put hardware in the classroom for them to learn with. Now, I am going to, and this is mostly about schools and simulations. I am going to push back on HR, and I do push back on HR a lot, is you got to start giving these students coming out of school a chance. We've got to realize they're not going to come out knowing everything. Now, the fact that there's some 4-year universities that are coming out of that have never seen a piece of industrial hardware, that is a problem. But maybe they worked on this Allen Bradley Compact Logics PLC, and you use Siemens in your plant. HR, you can solve that on your own. So I know this was more of a heavy video. I usually try not to get into, well, here's a good example. You'll never see a video from me on AB versus Siemens. You got to learn the one that you need to learn in your area. But kind of going along with that exact philosophy, until there is a job description out there that says must know how to troubleshoot simulations, or must know how to troubleshoot or implement Raspberry Pi as an industrial environment, then we can't be using that.